Let's try a slightly harder example. So now we're going to solve for something. Mass of the meter stick. And we'll assume it's in the middle because it's a nice regular shape, it's rectangular, unless there's some uneven density of the wood, like maybe there's a knot on this end. We can assume that the center of gravity is right in the middle at 50 centimeters. The pivot point, the fulcrum, is located at the 85 centimeter mark, and we're going to use our 100-gram mass again, which is located at the 90 centimeter mark. So we set it all up. It balances when it's set like this. So now instead of having another weight over here, what's causing the counterbalance against this 100-gram mass and producing counterclockwise torque? Yeah, but what mass? The weight of the ruler itself. Now I always have kids who ask me, well, don't I have to do like a percentage here? So like if this is like 15 centimeters sticking out here and 85 centimeters here, do I have to do like 85% on this side? 50? The answer is no. Once you find the center of gravity, it's as if there's no mass anywhere else and it's all located at this point. So you can think of this as a massless ruler with a point mass right in the middle. Okay? So if we're going to solve for mass of meter stick, we'll do torque counterclockwise equals torque clockwise. The mass of the meter stick is what we're solving for, yes? What's the distance from the center to the pivot point? 35, good. Again, that's probably the most challenging part of this. And then we're balancing that against our 100-gram mass, which is,
cool.
Okay, which is how far from the pivot point? Right, good. And this is a little ruler. It only has a mass of 14 grams. Okay, let's do one more, and then we're going to finish up with fun demonstrations. So now let's make it a little more tricky. I'm going to tape a rock, and I'll have rocks here for you. I'm going to tape a rock to the meter stick. And so now the rock meter stick combination will counterbalance our known mass, which again is 100 grams. And these, don't forget, the masses are, like this is a 100-gram mass. These cups themselves have to be added because they're appreciable. This is like 20 grams. So when this is only 120 makes a big difference. That's why it won't be perfect. It won't be a perfect 2 to 1. It'll be like 120 to 70. Okay. All right, so we've got a 100-gram mass. Where's the fulcrum? 60 centimeters. Maybe I should put my glasses on. Fulcrum's going to sit at 60, and we know the mass of the rock meter stick combination. So what you did was you just randomly taped a rock anywhere to a meter stick, massed it, just the rock meter stick, and then set this up so it balances. Got it? Now you're going to do some math. The 100-gram mass is located at the 80 centimeter mark. So how far to the pivot point? Good. You guys are getting good at that. And then what's the counterbalance here? What's producing the counterclockwise torque? We know the clockwise torque. Yeah, the rock and the meter stick. And we don't really know, like for this one, we knew, hey, the center of gravity of the meter stick is right in the middle. We can use that as our attachment point for this, mass, pretend mass hanging there. But here we don't know what that is. That's what we're going to solve for. So we're going to find a spot, and it's the center of gravity of the meter stick rock, of Ms. Rock. Okay? So I'm just going to put an arrow there. That's our force. And we know what this mass is, so we're solving for x. So torque counterclockwise equals torque clockwise. 120 meter stick plus rock times x equals 100 times 20. When I solve for that, I end up with 17 centimeters. When I go backwards, so there's 100, 80, 60, 17. This spot is the 43 centimeter spot. You see how I got that? Just working backwards from the end. So now here's the cool thing. When you do this, take everything off except for the rock and put your finger right there. So that's your test in the real world.
That's something big like a bridge.
Yeah, we'll do problems with bridges too. Cool? Can do this tomorrow? I think I'll just leave the equipment in here. You guys, you're used to this room. So we'll do that. Hi, Andrew, go ahead.
So if you gave us a car to find the center of balance to test it, you want